Okay, so this video is going to be a flip lesson where we are not going to do this in class. This will be on the test for this first chapter, will not be on the midterm though. So you don't need to worry about writing this down unless you might need to write some things down if you feel like you want to study them for the test that's upcoming. So here we go. This is about the face of the Earth and the continental features and the ocean basin features. Okay, so we can look at the Earth's surface and divide it up into two principal divisions, continents and ocean basins. Continents are pretty flat regions that have the appearance of plateaus protruding up from the sea. The average elevation is about 0.8 kilometers or about a half mile above sea level. And while mountains may dominate the view of some people, especially if you live on the coasts, because that's where they're really near, they really make up about 15 to 24% of the land, depending on how you classify truly mountainous regions, like what are big mountains, where do you draw that line? And then you have ocean basins. The ocean basins reach an average depth of 3.8 kilometers below sea level, or about 2.4 miles. So, what causes the difference in depth and elevation? The differences are primarily caused by the average densities. Continents range between 35 and 40 kilometers in thickness, with an average density of around 2.7 grams per cubic centimeter. Oceanic crust is about 7 to 10 kilometers thick, with an average density of 3 grams per cubic centimeter. Because of these differences in density, the continental crust is more buoyant than the oceanic crust and thus floats up higher on the deformable rocks of the mantle, and that's why they stick up the way they do. Features for the continents, we just talked about mountains. We have mountain belts. The most prominent feature of the continents are the system of linear mountain belts, and while they might seem randomly distributed from when you look down on them, they're actually not. They're, for the most part, located in two major zones. You have the Circum-Pacific Belt, which covers the area we sometimes refer to as the Pacific Ring of Fire, which is going, all the way down here in South America, all the way up along the west coast, through the Aleutian Islands, out here around Japan into the South Pacific, Indonesia and coming down here. This mountain belt is caused by active subduction zones where one plate is sliding under another plate. And there are frequent earthquakes and active volcanoes along this belt. And we also have the Alpine Himalayan belt, also known sometimes as the Tethyan belt. I think that has to do with the when Pangaea split apart, you had the Tethys Sea that formed in there that separated these areas of Europe and Africa, and so that's why they call that belt that sometimes. These also, this is caused by the India plate crashing into the Eurasian plate, does have earthquakes and volcanoes, not as many as the Pacific belt, but there are some, there's some notable volcanoes you've probably heard of in this area. Etna, Vesuvius, Stromboli. Yes, Stromboli is an actual volcano. It's not just a delicious meat stuffed folded over pizza. And Ararat in I believe that's in Turkey is another one we've heard of. And there's a Stromboli on the left, looks delicious, and on the right is the actual volcano of Stromboli there in Italy. Now, geologically, these mountain chains are relatively young, about 65 million years old. And there are older mountain ranges, such as the Appalachian Mountains on the east coast of North America, which are over 300 million years old, and the Ural Mountains in Russia, which are over 250 million years old. These older mountains are generally lower in elevation due to weathering. They've had a lot more time to be worn down than the younger mountains. So even though the Rocky Mountains on the east coast are much younger than the Appalachian Mountains, the Rocky Mountains on the west coast are much younger than the Appalachian Mountains on the east coast, but the east coast mountains are worn down more, so they're not as high as the Rocky Mountains, which is why all the good skiing's out there. Okay. In between those areas, in the inner parts of the continents, they're generally pretty stable, and the interior portions have been like that for at least 600 million years. So these millions of years of erosion from flooding and draining and ice ages and all that has smoothed these areas out to be relatively flat. There's a picture. If you've ever flown across the middle parts of any of the countries like this is from America, and I've flown from east to west coast and back, and you look out your window in the plane, you just see flat lands, divided up like this, and it's pretty flat. Now, when you're down at the surface and you're moving along, you'll find little ridges and bumps and guys like, but from the upper, pie in the sky view, it's pretty flat. Okay, features of the ocean basins. I have two capital letters there. If you drain the oceans, you would see a great variety of features: volcanic chains, deep canyons, plateaus, vast expanses of relatively flat plains in there. We've got 60 plus years of oceanographic mapping now, and we've spent a lot of time now mapping the ocean floors and figuring out what's down there. And we can divide the ocean floor into three basic regions: continental margins, deep ocean basins, and oceanic ridges. So the margins. The margin is the portion of the seafloor that is adjacent to the major landmass. If you look at the east coast of the United States, it's pretty shallow for a long way out before it drops off, and that's part of this continental margin. Some of them are quite wide, like I just said. Some of them are narrow. On the west coast, the margin is very narrow, and that's because they have underlying continental crust. They're considered kind of flooded extensions of the continent. So the margins are continental, and it's just a little bit lower, and the ocean just kind of covers it up. And that's why it looks like that. So here we have a little diagram showing, the continental shelf drifting down to the continental slope and then down to the continental rise. And between the margins and the oceanic ridge are the basins. And parts of these basins contain very flat regions, which we call abyssal plains. But then we also have deep ocean trenches, which can reach depths of 11 kilometers. And although they're small and only a small fraction of the entire ocean floor, they're very significant features. We also have volcanic structures called seamounts, which sometimes form long, narrow chains on the ocean floor. And then we have the most prominent feature here, the oceanic ridges on the ocean floor. These form a continuous belt that winds around the globe, and it's like a mountain chain along either side of this ridge, but it's not like deformed rock that's been squeezed and forced up through tectonic activity. It's actually layers of igneous rock that comes up and gets uplifted and done in layers like that. So it's not like the mountains we have on the continents. And here's a picture of what it would look like if you just drained the oceans. And you can see, I'm going to bring the mouse in here so you can see, like, here's the ridge, right, running down, equidistant pretty much between North America and Europe and Africa and South America. And here you have the continental margin, and where you have this drop off down here, and look, you have abyssal plains, these mountain ridges, and all these features we have down here. And one of them is part of this ridge runs right up through Iceland. Iceland runs right in the middle of it. You can actually, if you're on Iceland, go from the North American plate to the Eurasian plate, in a short walk. And Iceland does have volcanic activity. This is the volcano erupting in Iceland. I believe there was a fairly large eruption somewhere between 2008 and 2016, because I think Barack Obama was president at the time, and I believe the president of Poland had passed away, and there was a big state funeral, and Obama wasn't able to fly over because they would have flown over that region, and it was spewing up all kinds of ash and dust and rock and stuff. So they decided couldn't fly that way. Maybe it wasn't worth him going, and he ended up not going So that's a pretty recent eruption that goes on up there. So that's our basic look at the face of the Earth, and we'll go into more detail in later chapters about some of these things, but I want to just give you an overview of that. And there might be a couple of questions on the test related to that. So any questions you have, please email or bring them into class, and I'll be happy to answer them. Okay, have a good rest of your day.